This video is about two common measures of association in epidemiology, which is about the odds and odds ratio. You may have heard of odds. It may be in a specific movie,
Happy Hunger Games, and may the odds be ever in your favor.
or music. When your professor says that the odds that you will pass on this course is 3.0, should you be happy or should you be sad? Odds is defined as the ratio of the probability that an event will occur. It may be that an individual will become ill or die within a specific period of time or age, versus the probability that it will not occur. We may represent odds as P, or the probability of success, or the probability that the event will occur, all over 1 minus that probability. If let's say the probability that this event will happen is 0.4, then the probability that it will not happen is 0.6. That's why the numerator is P, and whatever is 1 minus P, that's the denominator. So if your professor said that the odds that you will pass on this course is 3.0, may be represented by the odds of passing is equal to the probability of passing the course all over 1 minus the probability of passing the course. In other words, the probability of passing over the probability of failing. If the probability of passing, let's say, is 0.75, then the probability of failing the course is 0.25, or 1 minus 0.75. And dividing that, you will get a 3. It indicates that the probability of passing is thrice as compared to probability of failing. In rolling a fair die, suppose you're asked to calculate the odds of getting 3 or more. So odds is the probability of getting 3 or more, so that's 4 over 6, all over the probability of not getting 3 or more, and that is 2 over 6. In other words, the odds here of getting 3 or more is simply 4 over 6 divided by 2 over 6. And that will give us 2. So this means that the probability of getting a 3 or more outcome is twice as compared to having otherwise. So it goes to show that it's more likely that that will happen versus it will not happen. So it's favorable. So if a person you like, for example, says that the odds that I will like you is 1.5, that is favorable on your part. So more likely that he or she will like you than he or she will not like you. On the other hand, if he or she says that the odds that I will like you is 0.4, it means that the probability that he or she will like you is less as compared to the probability that he or she will not like you. So odds ratio is also called as the relative odds, or simply the ratio of two odds. Given this figure is a case control study wherein the relative odds or the odds ratio is used. Note that the direction of inquiry here is backwards. You have a group of cases, meaning they are the one who are positive, let's say, of the disease, and you have a group of individuals who are negative of the disease. And then you're going to take a look back whether how many of them were exposed and unexposed. Meaning you may still create a 2x2 table wherein it indicates positive or negative of the disease, these are the cases, and these are the controls, and how many of them were exposed and how many of them were not. So given this, let's say this is your A, exposed and positive, then that is A. And then let's say this is your B, these are the ones exposed who do not have the disease. And this is your C, positive of the disease but not exposed. And this is your D, those who do not have the disease and not exposed. So given this 2 by 2 table now, since odds ratio is the ratio of two odds, then the two odds involved are the odds that the disease is present for those who are exposed and odds of having the disease when not exposed. So we may see that the odds ratio is just the odds of having a disease when exposed and odds of having a disease when not exposed. So since that is odds, we may interpret this as the probability of disease when exposed over the 1 minus the probability of being diseased when exposed. All over the denominator here, probability of having the disease when not exposed over 1 minus the probability of having a disease when not exposed. Now, since this is a conditional probability, again, probability of A given B is the probability of A intersection B over the probability of B. So this part here on the numerator of the numerator is the probability of disease and at the same time exposed over the probability of being exposed. Then the denominator here is just 1 minus that. So 1 minus the probability of disease and exposed over probability of exposed. Then the denominator here, still using the conditional probability, that's the probability of disease and not exposed over the probability of not exposed. All over, since this is 1 minus that, so 1 minus the probability of disease and not exposed over the probability of not exposed. Now, we may use these four values in replacing these probabilities here. This part here refers to this. So that's A over the total, since that is probability, all over the probability of being exposed, that is A plus B. All over 1 minus this part here, disease, and exposed again, we have A over A plus B plus C plus D over A plus B over A plus B plus C plus D. All over this one here, deceased and not exposed, that is C. So that's C over the total over the probability of not exposed, that's C plus D. Next, all over the one here, 1 minus, this one is still C over A plus B plus C plus D. All over C plus D over A plus B plus C plus D. Now, since every part here has a denominator of A plus B plus C plus D, for convenience, we may just cancel them out. So what's left will be A over A plus B all over this 1 minus A over A plus B all over this 1 C over C plus D all over this 1 minus C over C plus D. Now, A over A plus B is divided by this 1. 1 minus A over A plus B, doing some LCD here, that's A plus B minus A, so we have B over A plus B. So that's B over A plus B. All over, this one is C over C plus D, divided by, this part is just D over C plus D. Cancel A plus B, cancel C plus D, so we have A over B all over C over D. That is the odds ratio. So let's now apply that in the 2x2 table. It has been established that smoking is associated with lung cancer. A group of researchers wanted to verify if it is true. Results from 29 cases and 271 controls are in the cross tabulation below. Calculate the odds ratio of having lung cancer among smokers versus non-smokers. So remember that a while ago, we have a group of cases and a group of controls. How many of them were exposed and how many of them were not exposed? So in this case, 29 here are the positive cases and 271 here are those without the disease. How many of them were exposed to smoking and how many are not? So suppose we have this 2x2 table now. Among the 29 positive cases, 23 were exposed to smoking, and among 271 patients without the lung cancer, 157 of them are smokers or exposed to smoking. Let's calculate the odds ratio. So this will be your A, this will be your B, this will be your C, and this will be your D. So applying that here, we're going to have 2.78. What does that 2.78 indicate? So it simply states that whatever is this, that's the odds of having a lung cancer when exposed, and this is the odds of having lung cancer when not exposed. So whatever are the values here in this, taking its ratio, it's 2.78. So that shows that the odds of developing lung cancer is 2.78 times when exposed as compared to not exposed. In other words, a person with lung cancer was 2.78 times more likely to have been exposed to smoking than was a person not exposed to smoking. You may also interpret that as the odds of lung cancer is 2.78 comparing smokers and non-smokers. Or some will interpret this as smokers are 2.78 times more likely to develop lung cancer compared to non-smokers. These are the possible ways of interpreting this odds ratio. However, if you're going to ask me, I would prefer this one, because this one clearly shows that this is a retrospective data. since it's stated here that more likely to have been exposed. So you may go to a website which is medcalc.org, as shown here. So all you have to do there is to put the four values, 23, 6, 157, and 114. And you will have these results. Now, let us see the connection of the odds ratio and the statistical test involving two proportions. The test involving two proportions may either be the z-test of two proportions or the chi-squared test of association wherein you have 2 by 2 table. Note that on any of those tests, your null hypothesis assumes that the two proportions are equal. Since the odds ratio is the ratio of two odds, which are the odds of having a disease when exposed over the odds of having a disease when not exposed. Again, odds is a ratio of two probabilities. So the probability of having a disease when exposed over 1 minus the probability of having a disease when exposed. All over this one, probability of having a disease when not exposed over the probability of having a disease when not exposed. Now, suppose that the probability of having a disease when exposed, these two values here, represents this proportion. Let's call this as P1. Let's say P1 over 1 minus P1. And then, another probability here, which is the probability of having a disease when not exposed, let's represent it by this one. Let's call it as P2. Now, since under the null hypothesis, it assumed that they are equal, meaning P1 and P2 are equal. So that means that P1 may replace P2 or P2 may replace P1. In other words, P2 here may be replaced by P1. So since they are equal, we may say that P1 over 1 minus P1. And since again they are equal, that is just P1 over 1 minus P1, which is equal to 1. So it means that if the two proportions are equal, it assumes that your odds ratio is equal to 1 under the null hypothesis. And it goes to show that if your P1 and P2 are not equal, which is the alternative hypothesis, then it follows that your odds ratio is not equal to 1. So with the null hypothesis of odds ratio being 1 and in the alternative hypothesis of odds ratio not being 1, remember that a p-value less than the alpha, or usually the 0.05, rejects the null hypothesis. So if the null hypothesis was rejected, you're going to claim in favor of the alternative hypothesis. Thus, a p-value less than 0.05, it indicates that your odds ratio, even in the confidence interval, does not include 1. So likewise, if the odds ratio is greater than 1, then we say that the exposure is a risk factor in developing a disease. So in this case, since the odds ratio is greater than 1, then the exposure to smoking is a risk factor in developing lung cancer. On the other hand, if the odds ratio is less than 1, then the exposure is a protective factor. Now, let us see the connection of the relative risk and the odds ratio. Relative risk is computed this way, and the odds ratio is computed this way. Now, suppose that the prevalence is low, meaning there are rare individuals who have the disease. So it goes to show that this value is very low. Suppose that is 10. Out of, let's say, the total, let's say, a big value. Let's say 1 million. Now, since this is low, rest assured that A and B are also very low. So that goes to show that A here and C here are very low. And in contrary, when A and C are very low, since this is just 10 and this is 1 million, we are sure that this is a very large value. So these values are very large. So meaning B and D here are large values, while A and C are small values. So that leaves A and B and C and D here, which becomes now the odds ratio. So it goes to show that when the outcome of the disease is very small, again, that indicates that A and C here becomes negligible. Then the odds ratio here becomes an estimate of the relative risk.